All right, you guys probably got a message saying the meeting is being recorded, and so we shall begin. Thank you all for showing up on this, typical. Well, of course, I guess it depends on where you're dialing in from. In Seattle here, it's kind of a brightish, overcast, cloudy, mucky sort of days. It's kind of typical spring for Seattle. But welcome, and I'm glad you guys could show up. And whoops, stop that. That's not what I wanted to do. There we go. So the meetings will be recorded and posted onto YouTube sometime later, hopefully sooner rather than later. Sometimes it takes me a while to get to it, depending on how busy I am. So I apologize for that, but I will try to get it up there. If you have a link to our YouTube channel, the SRS Clips and More, you can go in there, and even before I have it linked on the website, it'll show up there. So that's where it ends up, and then I just point to it from the website. We'll follow our usual agenda here, as you can see off to the side, or I mean on your screens. Please mute your microphones if you are not actually talking, so that we can kind of not walk over the top of each other. And do be sure to use the chat to share information. So the chat gets posted placed in the post for the meeting after the fact. So I'll go in there, I activate the links that anybody posts, so you can go into the chat on the website afterwards into the post for this meeting and click on any of the links, and it'll take you to whatever it was people provided. So so if you got something you want to share, throw it out there. And I will try to pay attention to questions and other things that pop up over there. So excuse me if I'm a little slow to do that. I've mentioned this a couple of times. I don't know if everybody that's on today has been aware of this, but the First Washington has a new facility that they're currently putting together down in Kent. It's about a mile south of where the old one was, if you visited that for any of our in-person meetings. We are hoping perhaps June, July timeframe that we can actually have our first in-person meeting there. So stay tuned for that. We'll let you know. They're they're right in the middle of first right now. So all the people and people associated with the facility are very busy, and they don't have time to kind of get it ready for the kind of use that we will have. So, but that's coming. New website it seems to be working pretty well. I'm got, all the old SRS website content is available there, and you'll see links in the announcement on the front page how to get to that. We're also working on getting the old Robothon website and that data accessible similarly. So I'm going to host that on the SRS website, and then Donna will link to it from the Robothon website. So that has contest results and pictures and other things from past events in there. So we're hoping to get that kind of up and in place and accessible here soon. We are planning to do in-person, or we call them hybrid meetings, where we will have a Zoom available running during the meetings when we get to go to the physical meetings, so that if you are not a local or you can't make it physically to the meeting, you can always plug in via the Zoom. And then of course the meetings will be recorded, and so kind of ratcheting things up from where we used to do our meetings, where if you weren't there, you missed it and it was gone, but now with the recordings, you can go back and watch any meeting and find stuff. So anyway, that is the plan. We'll probably need a little bit of assistance from whoever's there to help run that gear and make all that happen, but I don't think it'll be a big deal. I am still in the middle of doing robotics classes with some junior high kids, and currently using I've actually used all of these robots on the screen here, but I'm currently using the 3 the blue ones in the middle there, which are 3 configurations of the same kit. So I actually have, that's what these guys back here are. So I will show those off a little bit later. And I'm still trying. I have purchased StephenKaehler.com, so I'm creating my own website where I'm planning to have online classes for junior high kids or kids in that kind of time, in that age bracket, and do some sort of robotics thing, possibly using these kits or maybe something else. There's some definite advantage to these, so I'm actually hoping to share that a little bit later with you. Drive Electric Earth Day is this basically, that's kind of a funny term, but this whole month is basically filled with events. Most of them are in other parts of the country, but there's actually there's an event happening next weekend up in Mill Creek, and then there's another event happening down in Olympia the week after that, the last Saturday of the month. And the one next week I'm going to be gone for, but I'm planning to be down at the one in Olympia with my Nissan Leaf. First Washington events. First Washington is in full swing right now, so there are competitions happening. There are kind of some of the preliminary elimination rounds as the kids work towards the finals. So you can visit the SRS website, click on First Washington up at the top, and you can find out about that. Encourage support for that. Appreciate all the help. Robert has been giving me way many suggestions, and I'm a little behind on following up with some of those, but thank you, Robert, and it will continue to fill out our schedule. So I suppose when I say please solicit presenters, I mean, it's kind of like, well, I actually have lots of people to ask, so it's not like I really need names. But if you should happen to encounter somebody you think would be an interesting fit for presenting to us, please feel free to invite them to do so, and collect contact information and send it to me, please. So here's the current schedule. I will probably start working here in the next month or two. I'll start working on kind of filling out the rest of this year, which you can see we're booked all the way to September. So I love that. It kind of makes my job a little bit easier when we've got lots of folks out there into the future. So and then occasionally we'll throw in open discussions. I call them where you can, I'll probably, I or somebody can facilitate a topic. You go out to the web, find maybe some interesting videos or other things, and we'll just talk about it. We'll maybe watch a preferably short videos where we can just, that stimulate discussion and questions. So it's always fun. Nobody, I'm no expert on these topics, but at the same time, there's a lot of interesting stuff out there, and it's fun to talk about them. So if you got any other ideas there, just send them to the email at the bottom of the screen, and I'll add them to the list. I haven't looked. Let me see if if I see him on here. Tony Doug, I do not see. Let's see, 3, 2. Don't think he's here yet. Our presenter for today. I don't see him yet, so be watching for him. Matthias Mueller. So he is he's actually in Greece. So as usual, we're going to have yet another international presenter here. These last few months, we've had people from Zurich, Switzerland, Tokyo, Japan. Let's see, we had where was the other one? There was another guy from over in Europe, and now we're going to have a fellow from Greece. So this is I love that Zoom gives us this flexibility to be able to pull people in from far places. It's pretty cool. Let's see. I should have checked while I was just looking there to see if Donna is here. I know Lloyd is not here today. I don't see. Okay, so I guess I'm going to be your the Robothon updates. So the next in-person in-person event will not be happening until 2023. And the main reason for that is because dealing with the Seattle Center is turning out to be, shall we say, challenging. Getting them to commit on what we can do. They're currently saying, well, we'll allow one in-person event in a shared space, and the war folks with their combat robots are planning to be out there, but then we have to coordinate with that. We have to get, come up with T-shirts, figure out how we're going to sell them, and without in-person meetings, of course, it's a little difficult to actually sell T-shirts ahead of time, and because that's basically our primary source of funding for these things. So it's was kind of decided by the Robothon committee at the last meeting that that will not be happening this year in person. However, we are going to do another virtual event, a virtual exhibition. So you can see on the screen there, we are planning that for August 27th from noon to 3, similar time frame, and that's a Saturday. And it is open to people who want to present. There's 4 of us, including me. I'm going to do another presentation. I'm actually going to talk about these little guys back here in more detail. But if you are interested, I believe you can go to the Robothon website, I think, and register. If Donna doesn't have that up there, you can send me email me and I'll pass it on to her. Or if you can reach her directly, if you happen to have her email, contact her directly and let her know that you're interested. As the slide says, there are 4 people currently planned. We usually like to have an extra couple in case somebody drops out at the last minute. So it would be good to have 6 or even 7 people sort of potentially lined up for it. The SRS PopCan Challenge, here's an event. If you want to go to a physical contest event, this one will be available. If you've ever been to the Sunoco Makerspace up in near Payne Field, it's actually it's literally across the street from Payne Field. They are going to have an event on May 7th from 10 to 2 10 a.m. to 2 p.m. And you don't need to register or anything like that. It's just basically an exhibition event, so you can come there and you can see what they're doing. And then they're also planning on October 1st to host a PopCan challenge at the same location. So I'll put these, and this one's also, this is going to be Zoom, so if you can't make it physically to the event, you could always plug in that way. So I will get these things on the website and have them out there where you can see them. So any questions so far here? I've just been kind of bulldozing through this stuff.
Hey, Steve.
Yeah.
Well, I mean, should we be organizing some type of year-round fundraising that we can do that includes the T-shirts, but other things so that we can save up ahead of time for the next Robothon for 2023?
No, that's an interesting idea. Why don't you have some specific ideas about how we might do that? Or you just
Not precisely at the moment, but I can drum it up a little bit and bounce some. Try and figure something out in the next couple of weeks to suggest. I was just thinking that we're stuck with the online meeting format for a whole nother year, so I'm just thinking maybe we can do something different proactively that would allow us to save up the money ahead of time so that we could be ready to go for next year when we're negotiating with the Seattle Center. And I hope we can still get a slot on their schedule, because I know that can be difficult too.
Yeah. I don't know. I'm not sure how normally it's very difficult just to get a slot because there's so many people that want to get in there, and weekends, if you've ever been down there, you can go down there practically any weekend of the year and there's something happening there. The place is very popular facility for booking. I'm not sure if that's the way it is now, kind of this, very near post-COVID kind of time. If you have some specific ideas, why don't you just send them to the Seattle Robotics Society at Gmail, and I'll pass them on, and we'll kind of chew on those. It's an interesting idea. If there's something that's not a ton of work for us that would be able to do some of that kind of fundraising, that could be helpful. Yeah, thank you.
Right. Yeah, and I'm always interested in getting different T-shirts and stuff made. I think that's a great idea, but there may be some other things we can do that doesn't take as much time to get put together.
Right. Just out of curiosity, you're just showing up as Calvary Chapel Edmonds. Who am I actually talking to?
I'm sorry, Terry James. The problem is.
Terry. Okay. I should have recognized your voice, but you know how Zoom does it. Zoom really messes with it. So, thanks, Terry. Yeah.
I'll fix that in a minute.
Yeah. No, that's no problem. I just. Yeah. Okay. Any other questions or any other questions or comments or anything? Okay. Okay, so this one, then you've I just told you about that. So our virtual exhibition, and according to Donna, you should be able to go to the Robothon website and sign up for it. And I'll trust that that's true. I actually didn't check it since I made this slide. So after the meetings, we can continue to have online discussions. I'm going to have to bug out early, but I can leave the Zoom session up, but we will stop recording at that time. So, but otherwise, feel free to hang out with other people online here and continue to talk about whatever topics are of interest to you. Wow. Ooh. Oh yeah. I guess I killed about 10 minutes at the beginning of the meeting with my futzing around with my audio, didn't I? So sorry about that. Well, anyway, we are at the Around the Web, where this opportunity for you guys to share anything that you've got. I have a few fun little videos that I can throw up there if nobody has anything off the bat. But if there's any sort of questions or comments or discussion or anything like that, I'd love to carry on with that. So anyone out there want to jump in?
In a few minutes, I can give a robot arm mini update, but I need to set up a camera or something. So
okay, all right. Well, I'll tell you what, I will do. Let's see. I'm gonna. Maybe I will. I'll start off with this. Now, hopefully, this will actually get around to loading here. It looks like it's taking its time. So I will apologize in advance for this kind of silly video, because I was looking for videos having to do with the pop can challenge, and this one popped up at the top of the list, and it's a totally silly video by these two teenagers, and I hope you find it amusing. I thought it was kind of hysterical what these two boys actually did with their what they call a pop can challenge. So so here we go. Let's see here. Make it big. So there probably, well, there actually is audio to this. I know you're not hearing it, but teenagers being teenagers doing goofy, silly teenage stuff. So as you can see, they are smashing pop cans with their foreheads and their heads. And you know, I had to admire the creativity of, you know, pop can challenge, smashing things to your forehead. And it's like, yeah, of course, the two of them, they ended up with headaches as a result of all of this. And it's like, okay, boys, you know, teenagers will be teenagers, right? You kind of gotta wonder about kids. Let's see, whoops, get to the right slide deck. So anyway, sorry about that. You know, I had to show that because it was like pop can challenge, you know, promo for the pop can challenge here. How you doing there, Greg? You close?
Just a second.
Okay.
Talk amongst yourselves.
All right. Let's see here. If I can, what I'm hoping, find the speaker. Let's see. Select a speaker. Leave computer audio. Oh, let's see. What? I'm gonna just check something here quick. Oh, that. Oh, okay. That's all that is. All right.
Really, what the heck?
All right. Let me see here. Try another one here. Come on. All right, let me see here. Is anybody, let's see, are you hearing anything from that? No? It's not making any noise on my end either. That's kind of interesting. I wonder what the so maybe I'll just talk a little bit about what I can see here, but this is essentially an industrial robot that is sort of replaced, in a sense, can replace certain functions of restaurant workers. You know, you can see this guy is doing deep fryer kinds of things, and you know, I have no idea how much a thing like this runs, but you know, I don't know if perhaps some of you, even in your younger days, may have done some of this kind of work. You know, if you worked in a fast food place or a fish house or, you know, burger joint or something like that. You one of my first jobs was working in a restaurant, and we got to do stuff with deep fryers, deep frying shrimp and chicken and other kinds of things, and then cleaning up at the end, you know, which is always fun. And of course, you got to be very careful around that the oil, because it's extremely hot and very, you know, severely burn you if it even touches you for even a fraction of a second. And so they're you can see they've got this very elaborate system for sort of being able to track what the robot can track what it's doing, what's in the particular fryers, where to get that stuff from. It's always interesting, when sometimes the videos will they'll speed things up because the robots are actually relatively slow in real time. Although I believe that looks like real time there. So. But I believe this is something being developed over in Asia, which probably doesn't come as a great surprise because they do love deploying robots everywhere. I was looking at some videos. I was looking at some videos where I think it was a video about robots being deployed kind of in normal situations, and so people, they'll put maybe you've seen these videos of these little dinosaur. The dinosaurs can talk. It's a robotic dinosaur, kind of like what you might see in the movie at Jurassic Park or something. But these little dinosaurs will interact with guests, let's say at a hotel, and they greet them, and then they say silly things, and I think they're probably remote controlled, or at least to some extent remote controlled, or there's a person hiding somewhere who's interacting with the guest via microphone and video camera or something like that. So the robot appears to be alive, but isn't really, and can ask questions and hear answers and respond to things like that. And of course, we know the robotic technology is not anywhere near that point yet in the real world, but you can fake it pretty well if you do it right. Perhaps some of you, I think I showed some pictures and videos from it's like I guess you'd call it a valet in a hotel, where there's this little kind of looks a thing about the size of a trash can that has a lid that opens up on top, and the staff at the hotel can put items to be delivered to a room in the hotel into the robot and then direct it to go to that room. And the robot can find the elevator, can get itself on the elevator, get up to the proper room, floor, go down the halls. It's got, I don't know if it scans just the room numbers posted on the with a camera, or if there's some kind of barcoding or whatever, but the robot can figure out where this thing needs to go. It knocks on the door when it arrives, and then pops open if the door is answered, and then the guests can retrieve whatever they were provided, and then the thing returns back down to the lobby, or if it's got multiple compartments, maybe it can make multiple deliveries at different places in the hotel, and then come back when it's done. So there's actually one of those in Tukwila, a new hotel near South Center in Tukwila has one of those, and I haven't been by there lately to see if it's still there and still being used, but they had deployed that a while ago, and it's kind of interesting. And then of course there's security drones too. When my wife and I were in Texas here last summer, there was a security drone that was wandering around along with a guard. There was a human guard, and then there was the security drone, and they were just kind of circulating around this one area. And the drone itself, if I remember right, it was a kind of a bullet-shaped thing, and I'd say about 6 feet, maybe 6 feet tall, something like that. And it had cameras all around it, and I don't know what all it was capable of, but I believe that part of what it did was these cameras would relay video data to a central security center in the building. So the people remotely could monitor everything that the robot could see and hear, I guess. And don't know how. I think they're kind of expensive. Don't know how robust they are as far as if somebody was to, you know, back up to one of these things with a van and flip it into the back of the van and drive off, you know, to steal it. I don't know if it's too heavy to for that to happen, but it seems like it's a possibility that somebody could, hey, that's a kind of a cool piece of tech. I think we'll go take it. So.
Did you say it was a drone as in flying, or it's wheeled?
It's just a wheeled drone. Yeah. So it's
Okay.
it's like a companion to a human security guard. And obviously there are flying surveillance drones out there too, you know, but all right, so let's see. How you doing there, Greg?
Yeah, I can give a brief update.
Okay, let me see. I'm going to go ahead and stop sharing my screen.
So I've got a second login to Zoom, so you're not going to see anything in the one with me in it. If you pull up the other login, you'll see the robot arm on the cluttered table in the cluttered office. So my current challenge, so I got my driver board. So I've got a custom made driver board, stepper driver board, got that installed. And the what I ran into, and it's using the TMC, technically they're TMC 2226 drivers, which are functionally identical to the TMC 2209 drivers. The only difference is it's a different chip package. So what I ran into was the elbow joint. So I've got the shoulder joint, obviously, is the one that's going to require the most torque. But the one advantage I have with the shoulder joint is the fact that I can offset some of that with springs. I've got one spring on here, and when I fabricated the mount for the other side of the PC board, I put another attachment point so I can run another spring over to the other side of the arm. So I can offset some of the torque requirement with springs. I can't do that with the elbow because of the fact that you know, the angle where the most torque would be required changes as the shoulder turns. And what I discovered was it didn't have enough torque to the stepper motor would stall out just as it was trying to lift up the arm, let alone, you know, I don't have a gripper on the end. I don't have a full can of pop. But at that point, I didn't know, is it that the motor's not strong enough or the motor's not getting enough current? The TMC drivers that I'm using, there are a lot of configuration settings. They have a serial connection between the microcontroller and each of the drivers, and you can set current and you can turn on and off all these things that have great marketing names, and I can't figure out what they do. Stealth chop and cool step and all this stuff. So part of me is regretting going with these smart drivers. Maybe I should just go back to some DRV drivers. But in effect, that's what I did. So I this last Thursday, I just used this, you know, plain Jane CNC shield, hooked up that particular motor to it, and just stepped the motor, and it had significantly more torque. So that tells me that, you know, I'm not controlling these drivers properly. So that's been my my stumbling block at this point, is developing enough of an understanding of those drivers. I did find a couple different Arduino libraries. I've settled on the one that I think is just called the TMC library. It handles many of the different TMC driver chips, and there's little to no documentation with the library. So I'm having to do, what many of us hate doing, and that is go back to the data sheet and read it. So that's where I am. I just want to add, I've never used these TMC drivers before. I recently updated my 3D printer with a SKR version 1.3 motherboard and put some of the TMC drivers in at the 2208 drivers into that motherboard. And when they say that those drivers make your stepper motors run quietly, they are not exaggerating. I will leave my room with a print going and then come back towards the office and think, boy, that finished early. No, it's still going. I just can't hear it running down the hall. So those are amazing.
Any idea how they're doing that?
Magic.
Okay. Yeah. There's a lot of that in this hobby, so.
Well, they could be doing micro stepping.
Yeah, I bet they are.
Well, they do. They do 200. They interpolate 256 step micro stepping. That's one of those modes. It's the stealth chop mode, I think is what it's called. But it really does work.
Hey, Greg, have you thought about anything to do with inverse kinematics for controlling your arm?
Well, in a previous version of the arm, the one that was driven by RC servos, I did get to the point where I had it coded so that I could give it essentially an XYZ target for the gripper, and then it would calculate all the angles necessary. It was that can be very complex. It was relatively simple with this arm because of the lack of the lack of range. So the shoulder only does 90 degrees, right? The elbow does 180 degrees. And then the wrist does 180 degrees. And therefore, there's really only one solution to any given position within its range of motion. So that made it fairly simple.
So this is software that you wrote?
Yes.
Okay. I was wondering if anybody had used the Move It 2 package from Ross 2. I have been having a hell of a time even just getting it downloaded onto my computer.
Yeah, I don't use ROS anywhere in my robot, partly because I can't quite figure out what it's good for. I know that there's lots of packages that are written to use ROS as their means of interacting with the rest of the robot, but I haven't figured out how to incorporate that into mine. And I've got lots of Arduinos and only 2 Raspberry Pis, so I couldn't figure out where to fit ROS into that.
Yeah, okay.
All right. Let's see here. Okay, let's see. Got it. Remove the spotlight on that. All right, so now let's see here, back to gallery view. Okay. Let's see, I was just kind of looking through Thomas, Terry. Okay, I don't see our presenter yet, so I'm just going to reach out to him.
Another wacky YouTube video while you do that, Steve.
Yeah, please.
I don't know if I can present here. Do I? I don't know that I can share my screen though, Steve. Oh, there it is. I see it. I see it. Never mind. My fault.
Okay. Yeah, no problem.
Let's see if I.
I also got one that we can share.
That one is really cool. So I love it. So that's using looks like a lot of these are using like the gyroscopic effect then for balance.
Yeah, and this is actually, we're going to jump ahead here past all
The
this.
reaction wheel.
To adjust the reaction wheel past the JLC PCB add.
Huh.
So I believe he has programmed this thing to, so you suddenly accelerate in one direction or another in order to give a rotational force on the robot, and then you slowly slow down in such a way that you can maintain your position without having your reaction wheel spinning at a high speed, and then you can use it again.
Yep.
But if you don't do that, then you get to the maximum speed of your motor and then you can't control anymore.
Yeah, that
Okay.
happens too.
Oh, that's really clever.
So
But that last one is an Omni wheel that has powered wheelets.
right.
Oh, really?
So
Yep.
it doesn't have any reaction wheels or gyros. It just has a two-directional Omni wheel. See the little wheelets? He went through two versions of this to come up with the good one.
Yeah.
And there are little gears in there that drive all those wheelets.
Huh.
So they're driven from the axle. So the axle on one side drives the whole wheel, and the axle on the other side drives the wheelets.
Wow.
So he makes all sorts of 3D printed robots, this guy.
Yeah.
Oh, yeah.
Amazingly productive.
Yeah.
And he has sponsors that are 3D printer companies and
JLC
filament
PCB.
companies, etc.
Yeah. Yeah. That I've seen other stuff.
I'll drop the link to his channel in the chat here for you guys.
Yeah. Yeah. Yeah, he did. I watched a YouTube video about a BB-8 robot that he took apart, kind of figuring out how this thing worked. And then, of course, wants to kind of go at it with his own ideas and improve upon the original design. And it was it's kind of interesting.
That was like 6
Cool.
years ago.
Yeah,
I just
yeah,
looked
that
at the
was,
channel.
yeah, right. Let's see here. Okay.
So, Steve, if you need more filler, Chaz put a link to a video about something that Disney is doing that is, in my mind, absolutely incredible.
Okay. Let's see here. Turn my chat window back on again here so I can see it. Okay.
But I think the audio will be very important. So if we can't share it with audio, we may need to leave it to people to view on their own.
Okay. Okay. Let me. Okay. Oops. Stop it. Okay. All right. Give me a. Dang it. Can't back up there.
I can try sharing it if you would like me to.
Well, let me give this just a bit. Okay. All right. Now what I have to do is get back to my share in the right spot here. Share. I think I've got it. Oh, there. Okay. And I just saw something else too that I probably need to. Well, let me see. Yeah, you're not hearing that, are you?
No.
Greg, why don't you go ahead and give it a shot? See if it shares from your end. We got to stop sharing here on my end. Okay. All right. I'm gonna have to play around with this, figure out why I'm having issues with the audio here on my end.
Now there is a share sound checkbox when you go to share something. Guess I can go. Yeah, a second. I gotta get. No, it's not going to let me. At the moment, I have to quit and come back in again. Sorry. So when you tried to share it, Steve, did you have the share sound checkbox checked? Go for it.
Not hearing anything right now, Steve.
Looks like Greg disappeared off of the meeting here. I'm guessing that he's just. Oh, there he is.
I had to
Hi,
restart.
guys.
There's Matthias. Okay. Hi, Matthias.
Sorry. Hi, how are you?
Let's see, I'm not hearing you for some reason.
We are.
We can hear him.
Matthias, if you can hear us, Steve's not
Yeah.
getting you on audio.
No, I can hear you guys.
I know
also.
what it is.
Fine.
I know what it is. Okay, try it now.
Can you hear me now?
Yes. Yes. Okay. Well, Greg, I think we can. I think we'll leave that video to people to view on their own. We have Matthias here. Glad you could join us. So it's like it's Saturday night there, right, in Greece?
Yeah. And I
Yeah.
wasn't really planning to be here, but it spontaneously happened. So sorry if my internet connection is not as good as it should be.
Okay. So I take it that that's not a real background behind you there.
I wish, but I'm pretty close to the sea though, so it could be.
Okay. That looks a little further. Well, I don't know. That might be about how far south you are, but yeah. Whereabouts in Greece are you exactly?
I am in Thessalonica, so quite far up north. We spontaneously came here to support some project and helped build a tree house. So now we're almost ready to go back home.
Oh, that sounds like that's a fun excuse to go to a cool place like Greece.
Yeah.
Yeah. All right. Well, since you're here and you're online, I suppose normally we would take a break about this time, but I think we'll just launch right into whatever you have to share with us there. And you're going to talk about OpenBot today, then in particular. That's your plan?
Yeah, that's the plan. And I'm sorry if I'm late. I mean, I thought that this would be the time slot, but I saw your email like a few minutes ago about when I would join. So I hope that timing is fine.
This is actually, the timing is perfect. Yeah, you're no problem. We always find things to talk about, and we were just kind of shooting the breeze here and killing time. And I was just I expected that you might join us earlier, but I mean, that's not a requirement. Presenters want to join at the time that they jump in. That's fine. We're a pretty easygoing group here. So, okay. Well, let me see here before we. I am going to, let's see. How about? I think I got. Everybody is seeing me. So let me see if I can. I don't know if there's an easy way I can change that. I think I can. Let me see here. No, I guess that's let me see what would happen if I do that. No, that just leaves my name up there, huh? All right, I'm gonna do it this way. There. Okay. All right. Is everybody seeing Matthias on the? Can I get a thumbs up from somebody?
Still seeing your name.
Oh, you're just seeing my name?
Yes.
Oh.
I think that's up to us. If we double click on Matthias, then he'll go full screen. So
okay. Why don't you? Yeah. So why don't you go ahead? Okay. So everybody go ahead and do that, and we'll. So I will just let's see here. Just give me a quick sec here. I'm going to just going to grab a little bit of background there. I went to your LinkedIn profile and some of the references there on the web about you. So just gonna kind of just a little brief background then. So Matthias Mueller holds a Bachelor of Science degree in electrical engineering and a math minor from Texas A&M University. In his early career, he worked at P&Z or P plus Z. I'm not sure how you say that. P&Z Engineering.
It's P plus Z, yeah.
Okay, as an electrical engineer developing mild hybrid electric machines for BMW. Well, that sounds like an interesting thing. He obtained a Master of Science and PhD in EE from KAUST. Is that correct? Is that how you say that? KAUST?
Yeah.
With a focus on persistent aerial tracking and sim-to-real transfer for autonomous navigation. I was looking at some of the stuff you worked on. You've got these are some pretty fascinating things that you've been involved with. So we would love to hear about some of those other projects as well.
Sure.
He's a published author, 15 different publications that he's contributed to, and his extensive experience in object tracking and autonomous navigation of embodied agents such as cars and UAVs. So with that, I will introduce Matthias Mueller and take it away.
Right, so then let me quickly share my screen. Let's hope technology works as expected.
It's been one of those days for me. So.
All right, are you guys able to see my screen?
Yes.
Yes.
All right. All right, so I'll get right in. I have about 50 to 60 slides, but feel free to stop me at any time if you have some questions or want to discuss anything. So I'll talk a little bit about OpenBot today. And yeah, the talk is titled after a research paper we published about 1.5 years ago with the same title, Turning Smartphones into Robots. Now, let me just motivate a little bit embodied AI. I mean, this is, essentially what I work on. And at Intel, I lead the embodied AI lab, and, we look at a lot of different things that revolve around embodied AI. So let me just, kind of define the term a little bit and, tell you why I think it's interesting. So embodied AI is, basically at the intersection of many exciting AI technologies. So it involves natural language processing, computer vision, learning from experience, and robotics. And the idea is really to bring artificial intelligence or intelligence, fairly close to what humans have into some embodiment, usually some, sort of robots. And yeah, one big aspect, and as you heard from the introduction, it's something that I'm quite excited about, is also sim-to-real transfer. So in simulation, it's not as difficult to learn a lot of this complex behavior, but it's quite a challenge to then transfer this onto real physical systems that actually do something useful. And yeah, this is the last part, and probably the part that I'm most excited about, rather than just developing some really fancy algorithms, that you can write papers about or, get good results on some leaderboards, to actually put things in practice, deploy them on real systems, and show that the algorithms that we work on are useful to do something. So yeah, what are some things that we need to make progress? So this is more from a research point of view, but I think one big part, as in all of AI, is tasks that are well defined and standardized, so that different people working on this can measure what kind of progress they're making, and also data sets. Simulators is also a big one, and in our team, we also have some work along those lines. And then, in general, tools such as Mojoko, Open3D, and so on. And then also robots. Now, I'll just briefly, for a minute or so, talk a little bit about some things going on in our kind of larger group. So one project, for example, is Open3D. It's also an open source tool for like 3D data visualization. So if you're interested, feel free to also have a look at that, and also feel free to ping me if you have any questions. Another big open source tool that came out of our group is CARLA. So it's a very photorealistic simulator for autonomous driving, and we're actually working on an indoor variant also that can also be used with OpenBot. So yeah, again, if you're interested, feel free to check out the open source CARLA project and play around with the simulator. And then, one more thing that I quickly want to mention before getting into some more details, and I think especially in this audience, this would be quite interesting. We have quite a lot of research going on with real robots in collaboration with universities, for example, with ETH Zurich and Marco Hutter's group. The top one where we learn from data very robust policies that can control these quadruped robots to go into really rough terrains. And then at the bottom, we also trained policies that can fly these high-speed drones and perform very acrobatic maneuvers. So this is maybe enough for now, just a little bit of context and also research that we do. And maybe one more thing to mention is the Embodied AI Foundation, which houses some of these open source projects that come out of our group. And the idea here is to grow these projects, make them more mature and make sure they stay completely open. And I briefly mentioned Open3D and CARLA, and now there is also OpenBot, and this is what I will focus on now in the next couple of slides. And the idea of OpenBot is really, so as I have shown, we have a couple of previous successful open source projects and also very exciting research, but most of this is not really accessible for most people. Like for the drone example and the quadruped example, these are extremely complex systems that require a complete robotics lab with 4 or 5 people that are experts in the hardware to build a software stack and everything around it. And then it requires kind of cutting edge research to make these systems work and do something interesting. And the vision behind OpenBot is to have a low cost accessible platform that can be used by anyone, and then using smartphones to run AI algorithms to make these technologies accessible for education, for research, and so forth. And I'll briefly mention this at the very end. So beyond doing education and making research accessible, there is some additional benefit in having such a low-cost plug-and-play platform, which is scalability. Since these types of robots are extremely cheap and can be operated with a smartphone, it's much easier to scale such a system up to like hundreds or thousands of robots and do some distributed learning than with currently existing robots. Sorry, was there a question? I didn't quite understand.
You got some.
I'm not sure if it's my internet connection, but if there was a question, maybe I'll quickly look in the chat.
I think that was just somebody had a microphone open. So go ahead. Everybody's muted, so please continue.
All right, great. Okay, so then let me expand a little bit on the motivations between the OpenBot stack. So a lot of the current robots are quite expensive or have limited capabilities. You usually have to make quite a trade-off. You can get these very low cost robots for $50 to $100, but usually they cannot do a whole lot. Or you need to shell out $500 or beyond to get some very capable robots. Also, hardware is usually quickly outdated. Camera technology gets updated quickly. The same with compute. Then, set up an operation is oftentimes not straightforward. Most robots, for very simple tasks, maybe you can get away with just like Arduino or some very simple Python programming, but for more sophisticated tasks, you often need to master multiple tools, maybe even be familiar with ROS, and so forth. And then, kind of as a result, I think, there's a lot of improvement because there's obviously additional projects as well, but robotics education still lacks quite a bit of exposure to AI algorithms, and a lot of the robotics education is still limited to fairly simple tasks, such as line following, or like very basic obstacle avoidance with a sonar sensor and so on. And then the second part, which I already mentioned a little bit, is robotics research at scale. So if you wanted to do some research in distributed learning, so something that you could do that Tesla, for example, can do with a very large deployed fleet, that's something that's very difficult. There are very few like companies and institutions that can afford this type of research where you need hundreds or thousands of robots deployed. With such a low-cost platform, this is much easier. So then here are a few related projects in the low-cost robotics regime. So there's kind of the robots that are more marketed as toys, like the DJI RoboMaster, and the AWS Deep Racer, the chatbot from NVIDIA. Then there are like fairly successful educational projects such as the DuckyBot, Donkey Car, and so forth. But you can see, even if you go for a fairly simple robot such as a DuckyBot, you're already looking at $250 or above. So the idea here is to leverage a smartphone for sensing, for compute, and smartphones, they become more capable pretty much every day with new smartphones being released. Many of them already, with 2, 3, 4 camera sensors, very good IMUs, and so forth. And they're also powerful enough to run some pretty heavy duty AI algorithms, which if you were to buy just a computer to do that, you would also be looking at $200-300. So current smartphones go way beyond like a Raspberry Pi, for instance, in terms of the compute. So then the idea is to, just kind of take the robotics part out and, have this kind of $50 robot, which is a fairly simple Arduino-based robot with a 3D printed chassis that then has an interface for you to just plug in a smartphone that can run all the heavy-duty compute and can take care of majority of the sensing, specifically cameras, IMUs. The other nice thing on a smartphone is also that all of the sensor data, like IMU camera, is already synchronized on the smartphone. So we have developed kind of a simple mechanical design that you can just 3D print, and that relies on standard components like TT motors, Arduino, and so on, that you can get pretty much anywhere off the shelf. The electrical design is here, so it's fairly simple. I think anyone that has some interest in robotics or has played around a little bit with it might have seen, similar things and also built similar things before. And to make things, even easier and more accessible, we also designed a simple PCB that kind of integrates as much as possible. Basically integrates the motor drivers and some resistors for indicator LEDs and stuff like this. Has a header for an Arduino, so you can get these PCB made for like $5 or so, and then you just plug in an Arduino you can connect a couple of sensors, and you're basically done. You can then, just connect the phone via USB, and you have a fully functioning robot. Now, here's just a couple of pictures of how this looks like and how an assembly would look like. So on the left, you have the components. So basically a 3D printed shell, top and bottom, a phone mount, and then, the electronics. Here we have 2 optical sensors for wheel odometry, sonar sensor, Arduino, and the LN298 and motor driver, and TT motors. So it takes about 30 minutes to an hour or so to assemble, depending on your experience level. So maybe, are there any questions at this point, like more on kind of the robotics part?
Yeah, I just got a real simple question. So this looks very similar to a kit that I used with some kids.
Yeah.
Those motors, I assume that the little yellow part is just the gearbox on a standard permanent magnet DC motor. It's very simple. No
exactly.
encoder.
So these are just kind of standard, I guess they're called TT motors. So it's just a simple motor with a little plastic gearbox in the front. So you can, so this is just kind of one possible design that's 3D printed, but you can use any design you want. Like on the GitHub account, in the repository, we provide firmware for the Arduino, and we provide the Android apps. So, there's no requirement to use that particular design. You can just, basically buy any kit or build whatever you want. And then you can just use the firmware and the software.
Is it PWM control of the motors? So you got variable speed on the motors then?
Yeah, so there is also like a fairly simple communication protocol. So the phone just sends basically a value for the left and right side between 0 and 100%. And on the Arduino, that's just converted to a PWM signal. So, yeah. I'll show a few examples later, because we have actually, by now, I think maybe 5 or 6 different platforms in the repository. And the idea is really not, this kind of one particular design. This is just one example. It's more the system. Yeah.
Okay, right. Thanks.
All right. Yeah. So talking about the system. So this is, kind of a system overview. So you have, like on the left, you have basically the smartphone, which acts as the brain of the robot. On the smartphone, you can run, some neural networks, for instance, that process image data to produce some commands. You can also connect, for example, a PlayStation controller or any other Bluetooth controller to the smartphone, so you can control it directly. And later on, I'll show you a couple more things. So we have also built some network interfaces that you can, basically control through your browser or Python or, kind of whatever you want. And then on the other side, you have the robot. So the robot is connected through USB to the smartphone. So it's just, standard serial connection, and gets the high-level commands, like how much to go left and right side, essentially. And then the Arduino on the robot converts this to PWM signals and actually drives the car accordingly. Then for the software side of things, so on the Android side, you have an interface that can accept, various controllers. So Xbox, PS4, basically any Bluetooth controller you can connect to the phone. And basically this will be parsed within the app into like vehicle control, indicator commands. There are a couple of different modes of controlling it. So either like a tank in like dual drive configuration, or more like a video game mode. So there's basically this interface in the Android app. Then there is graphical user interface with a couple of different screens for different functionalities. Also, there's some audio feedback and so on. There's also simple state estimation. So for now, it's very basic, but in principle, you could also use AR core. And one research project we do, and then using AR core, you can essentially like localize yourself within like a space. We then also have a data logger that allows you to capture images, IMU, GPS, synchronized with controls and indicators on the vehicle. And this is used for then like training some driving policy to do some sort of autonomous driving. Then there's also components in the app that allow you to plug in like neural networks that get executed in real time, that process images and then produce like controls. And there's some like post-processing stuff on the robot as well. Like on the Arduino side, PWM control, and then some low-level code for operating some LEDs, indicator lights, doing wheel odometry, monitoring battery voltage, and so on. And this actually by now we have extended with a bunch of more things like distance measurements through sonar, taking measurements from some bump sensors to detect collisions and so forth. All right, so this gives gives a little bit of context on how the software works. And now for the next part, I would just talk a little bit about two applications that we have on the robot. The first is person following. There we run an AI model for object detection. So you can detect various objects, for example, a person, and then track this object like through time via visual servoing. So basically, the AI model will detect the object of interest, and then based on the location in the frame, controls will be produced automatically, and as a result, the robot tracks that object. And then autonomous navigation. So here, the idea is to just collect some data of autonomously driving, of driving some route, and then training a neural network that will do the same trajectories autonomously. And from kind of a research point of view, we investigated the impact of having diverse data, like using different phones, because every phone is calibrated a little bit differently. Might have a little bit different perspective. The colors in the image are a little bit different, and then also robots. So these low-cost robots, they all behave a little bit differently, because the quality of these TT motors, for example, and so forth, is not great. So some of the robots would have a tendency to veer to the left or to the right. And we also investigate what's the impact of that, and if a learned policy can cope with these types of differences. All right, so
before you go on there, Matthias, just a question. So on the personal object detector, can it, if there were multiple, if it knows a particular, let's say it starts with a particular individual, but there's more people come into the field of view, can the robot still stay tracked on the particular individual?
No, not right now. So in principle, it's possible to do some like proper object tracking, but for now we just use like object detectors and then like propagate through through time. But if there's multiple objects, it will get confused. Then it just picks. It always picks the one with the highest confidence.
Okay.
But what you could do is run some real object tracking algorithm where you actually draw a bounding box around a specific person, and then you build a model of that over time.
Yeah, I
But
would
we
expect
cannot
you'd
do
have
that.
to do that to make that work. Yeah.
Yeah. Right now we don't do that, but this would be something interesting to do in the future as well, for sure.
Sure. Okay. Thank you.
Great. So now the evaluation. The evaluation of the applications that I'll talk about now is done on about 10 different phones. So we picked out, a very diverse set, very different price points between like $100 to $700, to also see how capable phones are, especially entry-level phones, how much you can already do with them. So here the setup for this object detector. So this is a model, for example, like MobileNet, but in principle you can plug in any model that you want. In the app right now, we have a couple of different models. So we have MobileNet V1, V3. So these are slightly older, but they have already been heavily optimized for mobile phones. So on some of the more recent phones, they can run at like 100 frames per second. But then we have also integrated YOLO V4, for instance, which is a fairly a modern object detector. But then obviously the speed it can run on phones is quite limited. So even on some of the most recent phone, it only runs at maybe 10 frames per second or so. So then the bottom, I'm not going to go into details, but shows kind of the rough structure. So you have some image at the input. Then you have a convolutional network that extracts some image features, and based on these image features, it then detects objects in this image. There is a non-maximum suppression, which just means that it filters a little bit. Like if there's a lot of overlap between the bounding boxes, it filters those out. And then there's an additional filter based on object if you want to track, I don't know, like a water bottle or person or whatnot. And then out comes a bounding box that's somewhere in the image, and based on this, we produce controls. And here are some results. So this is across these 10 different phones. And we just did this evaluation with MobileNet V1 and V3. And what we see is, and here we had a trajectory that we did indoors, basically from my desk to the coffee machine and back. And then we did this 3 times. And what we found is that, essentially all smartphones are able to do this, and with basically 100% success rate, except for the Galaxy Note 8, which at the time was already 2 or 3 years old, and the Nokia 2, which is a super low-cost phone. So they are able to track, but they have difficulties if you quickly go around corners, and mainly because their frame rate is quite low. So like this really cheap Nokia phone, for example, only tracks at like 4 or 5 frames per second. So if you quickly change direction, basically it's not able to follow you quickly enough. But one of the interesting observations was that, for example, the Galaxy Note 8 was a state-of-the-art phone just about 2 years ago, when we did this publication. And this phone, only achieved maybe 6 to 10 frames per second, but phones that were released in that year at a price point of only like $150 to $200 were already able to run the model at close to 30 frames per second, because all of the modern phones now have specialized AI accelerators. So kind of the interesting insight was that even with fairly low-cost modern phones, you can run quite sophisticated AI models at very high speeds. All right, then let me talk about autonomous navigation next. So just to explain a little bit the pipeline on how this works. So the first part is data set collection. So basically, a human operator drives the robot around with, with a Bluetooth remote control. We're recording all of the control signals along with sensor data like images and IMU. We also inject some noise, and this is quite important to explore additional data points. So what happens is that, as the human operator is driving the robot, there will be, like, the robot will randomly veer to the left or right, and the human operator will recover. So later on in the learning process, this helps the AI model to know what to do if the robot, veers off path, like, how to recover. And then once you have collected this data set, and like we found that, you need maybe 30 minutes to about 2 hours for such a data set. We do some pre-processing, basically, synchronize images, controls, and so forth. Then some like normalization and some augmentation. Basically, we adjust saturation, hue, contrast, brightness, and so on in the images for training, and then we train a policy to predict the same commands that the human operator predicted per image. And yeah, so these these policies are trained per image. So not like on a complete video sequence, but per image. So also all of the decisions that the robot makes are always just for a single image, which has pros and cons. And the algorithm that we use here is called conditional invitation learning. It's something we proposed maybe 4 years ago. And the idea here is that in addition to the image and some sensor measurements, you have some high-level inputs, such as turn left or right at the next intersection. So you can think of it like indicator commands on a car that provide the intent. And the reason for this is, imagine you come to an intersection. And there are multiple options. You could turn to the right, you could turn to the left, or you could go straight. Now, for the robot, it's not clear what the robot should do, so it needs some additional input. And the main issue is, especially for a learned system, it's not like a human that just takes a random decision and then says, okay, fine, I'm just going to turn right. But the issue is, you have the same observation for doing 3 different trajectories. So you need to resolve this somehow. And yeah, in this work, we do this by just providing this additional high-level command. And like on a real system, this could come from, for example, Google Maps. In this work, we just provide this indicator command through the remote control. Then a little bit more the network architecture. So we have a pretty efficient neural network that we designed that has a fairly small number of parameters and can run faster than real time on all of the phones that we tested. And yeah, I'm gonna skip a little bit through this. We did basically a few more tricks on like the loss function and other things to make the training process more efficient. Then as training environment, we just trained those policies like in the office corridors, and here you can see a couple of trajectories. And then for testing, we defined some fixed trajectories like right left turn, closed left turn, double straight, open right, and then we evaluated basically all the different phones, robots, and so on these specific scenarios. All right. Yeah, so here are the results, and I'm just quickly going to summarize. Basically, what we found is that training a policy with data collected from many different phones is a little bit more robust, but not very much. So even if we train policies that are collected from a single phone and use data augmentation, this policy still tends to work on different smartphones. And yeah, we also found that if we train policies with one robot body that has certain characteristics, like for example veers to the right, they tend to transfer also to other robot bodies that have different characteristics. And yeah, I mean, most likely the reason for this is that by injecting this noise and doing these perturbations, the driving policy is able to learn how to recover, even if the robot is doing something that's unexpected. Yeah. All right. So this is just kind of a summary of the results, and I'll play a short video, or I mean, I have a couple of more cool videos. So maybe did everyone already see the OpenBot video? Because then I'll just skip over that.
Go ahead and show it. Yeah.
All right. So then let me just quickly show this, and I hope that this will work through the internet connection.
Yeah.
Does it show up? Let me.
Yeah, it's catching up.
All right, full screen is unavailable, but I mean, I can share the links later, so you can also watch it offline. But what you can see here, I mean, this is actually my daughter just going for a little walk outside, and then the robot is basically following her around, and this is the object detector that I just talked about.
So is it just using visual data for the distance between her and the robot? It's just purely kind of sizing her or something to
yeah, so
decide.
it's actually completely reactive, so it doesn't really take the distance into account. It just detects the person, and then it always goes forward and then goes left and right based on where the person is in the image. So very, very simple.
If she stopped when I assume she must have stopped moving occasionally. Does the robot sort of figure that out and just stop and wait for her to start moving again?
Yeah, so there is also like the sonar sensor, you can specify a threshold. So I think by default is if the person is within, I think 10 centimeters, it'll stop. And then it will only start applying controls again once that distance is more than 10 centimeters. But that's something that can be configured in the firmware.
There's a couple questions in the chat here. One of them is about iPhone support. Is there the apps that run on iPhone?
No, not yet. So at the moment it's only Android. Yeah, so we are quite interested to also develop an iOS app. But it's quite a lot of work, and this project is basically run in the Embodied AI Foundation, which is a non-profit organization. I also still contribute a bit to it, but it's not really kind of part of my main work in some sense. So yeah, if there's interest, or also if you know good iOS developer, like feel free to forward them to me, and I can talk to the foundation and see if they can also pay someone to actually do the work. Yeah.
Cool.
Yeah, and then here, this is kind of the autonomous driving stuff. So you can see it driving around autonomously in the office corridors, able to avoid chairs, people, flower pots. And then we also put it up on a different floor. So it looks somehow similar, but it's an environment that the robot has never seen. You can see here now there's kind of this wide open corridor, which is something it has never seen, and it's able to generalize to that and, you know, still able to drive along, which is quite exciting, and I didn't really expect that, to be honest. All right, are there any other, does it have boyfriend detection? Yeah, not yet, but it's something you could implement. So you could train, you know, in principle, you could collect a data set from your boyfriend or girlfriend, annotate it, and then train a model that can detect them. Yeah, boyfriend avoidance is also, I mean, you know, maybe you could even implement it to shoot like with a Nerf gun at the boyfriend. I mean, who knows? Lots of possibilities. All right, so then let me move on. I'm going to move a little bit to a couple of applications. So one is education. So this platform has been used now already by more than 100 students that have learned about AI and robotics using it. So one, you know, kind of standard task is to print out this little street, and then the students will first build their own robots. Then they'll drive around the track for like 20 minutes, collect some data, and then train an AI policy that will autonomously drive around this track based only on observations from the camera on the phone. And this is actually done. So this was now done in Singapore, South Korea, and also Germany, and with just $50 smartphones. So basically the complete setup is only $100, about $50 for the robot and $50 for a smartphone. Yeah, so you can see also if you position it somewhere along the track, the robot will automatically find the street again, and then, you know, kind of keep driving along the street. Yeah, so that's education. And then, yeah, ongoing work. So I already briefly mentioned, so there is quite a big community around this kind of initial, I don't know, project now. And focus areas are software development, extending the Android app. There's actually two. It's also possible to control the robot with a second smartphone. You know, continuing the development of the Python interface, web interface, and so on. Also hardware. So yeah, essentially people can build any robot they want, but we just want to put out a couple more examples of different platforms that people can build and put instructions out there for people. So this is for the hardware. So, you know, we want to develop new robotic platforms, complete kits, so people can also just buy off-the-shelf kits. Then education, we want to invest more resources in developing a full curriculum to teach robotics and AI. So the first part of this is already done. So there is actually already a curriculum now that's out on YouTube that was developed by our collaborators in Singapore. But we want to kind of go a step further and have a proper course on like Coursera or something like this. Yeah, and then here are also the contacts of the Embodied AI Foundation, which is basically in charge of the continued development of the OpenBot project. Yeah, and then on the research side, we are looking on using this platform for distributed learning. So learning from experience, you know, from like hundreds of these little robots, basically exploring different environments and learning from that experience. And we're also working on a photorealistic simulator that can be used with this OpenBot robot. So yeah, in the rest of the talk, like which is I guess about 10 minutes or so, I would just like to show a couple of cool videos and platforms, and then we can maybe take a few questions.
Okay, sounds great.
All right, so here, this is just kind of a collage of a couple of platforms that people have built. So, you can see different colored 3D printed ones. People have made it slimmer to fit on their 3D printer, converted into a tank. Someone developed this like baby Yoda that has kind of a smartphone inside and, is following him around. Someone has built an OpenBot completely made out of cardboard. And yeah, so lots of different designs.
Wow.
And yeah, then for the robot app, since the initial inception, we have made it kind of nicer and more extendable. So you can see there's quite a lot of different screens now. So this is like the one that we had initially that has all of the functionalities in one screen, but now we have this like free roam, that just looks a little bit nicer and shows you the most important data for just kind of driving around. There's a dedicated data collection screen that also allows you to connect to a web server that will automatically receive all of the data that you collect. This is just, if you connect a Bluetooth controller, you can check that everything works as expected. There's a dedicated screen for running the autopilot for object tracking. So here, you can also now select different objects. There's about 80 different object classes, including like water bottles, cars, bikes, motorbikes, all kinds of things. And then there's this model management screen where you can download different models for object detection. So we have, it's like 6 now. So basically there's some trade-offs. Some run faster, but have lower performance in tracking objects, and others slower, but have better performance. So based on your smartphone, you can kind of pick the model that works best. Now, there's also a dedicated controller app. So in case you don't have a Bluetooth controller lying around, but a second smartphone, you could install this controller app and then connect and remote drive the car through that app. It's actually not visible here, but you'll also get a live video feed on the phone screen. It's actually quite fun, I have to admit, driving it around with a second phone. There's also a Python interface, which is still in development. It kind of works, but not really amazing, to be honest. So you can, if the phone and the laptop on the same network, you can basically just drive through this Python interface. This is to, enable different applications that people might want to do. You also get a video feed, but the latency is too high to be useful. Then there's this web interface that actually someone in the community has developed. So this allows you to do the model training directly from your web browser, allows you to receive data there and sort the data all from the browser, which just makes it a little bit easier. And then also, since recently, we now have the possibility to control the robot through your browser with a Node.js server. So again, you just run a script on a laptop, you open up your browser, and then you get a live video feed in the browser and can use your keyboard to drive the robot around. So all of this is documented in the repository. So feel free to play around with some of those things and ping me if you have questions. Now, in order to make it more accessible, we've also developed some more integrated solutions. So this is like a prototype for a robot that could be produced at a larger scale. We use this internally for our research, but we also plan to make all of this open source. So this is the TT motor design, but now the electronics are all completely integrated, and it has a couple of additional sensors and LEDs. Then this is a variant that's a little bit more powerful. So instead of the TT motors, it's using the 520 motors with integrated wheel encoders. It has an ESP32. So you could, in principle, also directly connect to the robot through Wi-Fi and just do a bunch more interesting stuff with it. And yeah, we have actually also developed now, not developed, but built injection molds, and we plan, or yeah, like we plan to sell them through the Embodied AI Foundation. Again, another step to make this more accessible, so people that don't have a 3D printer or the skills to build a robot themselves, they can just buy them in a shop. And this is how they look like. So on the left, you can see some renders, and on the right, you can see some of the finished prototypes with the injection mold, little USB-C connector in the front, and then fully integrated electronics inside. Yeah, also in the repository, we have, we have put some instructions and made some 3D printed designs for retrofitting RC trucks. So basically, again, with an Arduino, it's very easy to just send the correct PWM signals to essentially any RC truck. And then, yeah, you just connect the smartphone and you can now do the autonomous driving, object following, all of that stuff with the RC truck. Another cool project is the multi-terrain rover. So in a couple of weeks, we'll open source all of the designs for that as well. So this one is able, to climb stairs and go through pretty rough terrain. So let me actually show you a little video of it. I think it'll make things more clear. So here you can just, see it driving around through grass, through gravel. Yeah, it's pretty rugged and fun. And here it's able to drive up some stairs. All right, and then here, this kind of a fun thing that we did now with one of the robots, which is an autonomous coffee delivery. So, we use the same framework that we used for driving around the corridors, but now we collect the data of the robot going to the coffee machine, and then you just press a button and it will autonomously, drive to my office and bring me the coffee. And yeah, again, like in a month or so, we plan to release a couple more videos. The goal is really to just inspire the community, to try out stuff and do cool things. Yeah, so maybe I'll skip a little bit forward, but it'll basically just drive here, turn around, and then go around the corner and bring me the coffee. Yeah.
I like the turn signals.
Yeah.
Nice touch. Nice touch.
And yeah, just recently in April, it actually snowed. So I just kind of beefed up one of the robots with a 4S LiPo and bigger tires, and then, was just kind of racing it through the snow. So again, this is just to give you some impressions. I mean, as I said, that the robotic platform itself is very flexible. You can, kind of take any robot you want and then just use kind of the system. Yeah, then let me show maybe one or two more videos, and then I think we're out of time. Here, this is the Fast and the Furious. So here, this is the RC truck with the person following, and I'm running. And after about 20 seconds, I'm out of breath, and the robot runs into me. So it's, it's also fun as a fitness coach. You just equip the RC truck with the person following and have it chase you. Yes, I can maybe share these videos later, because I think through the internet connections, maybe not as visible. But the point is that with RC trucks, it'll probably go at 20 miles an hour or so, and the person tracking is still good enough that it'll follow you around pretty reliably. Yeah. And then let me just give you a quick impression maybe of the simulator that we'll release in a couple of months. So, it's kind of this photorealistic indoor simulator that can be used to well, at least our vision from a research point of view is to use photorealistic simulators of indoor environments to train policies for autonomous driving in home environments that can then transfer to the real robots. Yeah. And then last but not least, I'm not going to go through the details, but another research thing that we're interested in is to do this distributed learning. And we have already built a system, and we're currently kind of trying this out, where the idea is that you have like basically a large number of crowd workers in the range of 100 or beyond that have these little robots driving around in their homes. These robots will like upload the experience to a database, and then based on all of this experience, we learn some autonomous driving behavior, and we push this policy back to all of these 100 robots, and they learn more. So over time, they will basically improve. Yeah, so that's it. And I'm happy to take any more questions if there are any.
Can you send me a copy of your presentation?
Yeah, I can do that. I mean, I'm not sure if I can do it right now, but when I'm back from Greece and have a good connection.
Yeah, no rush on that. No rush on that. Just at your convenience.
Yeah.
Let's see. It looks like there is TensorFlow done in hardware.
Oh, Flow. Sorry, TensorFlow.
TensorFlow. Okay.
Yeah. So I don't know what's meant exactly, but I guess for learning, like how TensorFlow is used, or I mean,
I was wondering if you had to get a special hardware microprocessor to do the TensorFlow added to the robot, or are you doing it using your laptop using the laptop hardware to accomplish it, type of thing? That's what.
So actually, the TensorFlow models, they run on the phone. So the hardware on the robot is you can just have an Arduino Nano that basically just sends PWM commands. So even like a $4 Chinese clone will do the trick. But then all of the heavy lifting is done on the smartphone. And the nice thing is, so basically, if you collect the data, you train a TensorFlow model on your workstation or laptop, and then you convert it to a TF Lite model, which you then push back to the phone. And the nice thing is that a lot of the modern smartphones, they have dedicated tensor cores that are optimized to run these type of models. So then, you can run even very sophisticated models extremely fast on smartphones.
Great, thank you.
We got other questions out there? This is a very cool project. I'm really tickled that you were able to share all this with us. I think a lot of people are going to find you'll be visiting OpenBot here and checking that out.
Sure. Yeah, feel free to check it out. And there's also a Slack channel that's linked on the repository. So also feel free to join the channel. There's a community, I guess, I don't know, maybe like 300 people or so by now. So if you want to build your own robot, do some cool stuff, feel free to use the Slack channel as well to communicate with others, ask questions. Yeah, I'll just post the link of the repository again.
Okay, thank you.
You should find everything you need there, and if not, feel free to ping me.
Yeah. Anybody else got another question before we let our presenter go? It's not actually as early as it looks in his background there. So it's what about 10 o'clock your time now?
No, it's 10. Oh yeah, it is actually 10 p.m.
Yeah. So
wow.
So it's he's a Well, thank you so much for fitting us into your schedule, your spontaneous Greece trip here. So where are you normally? You're just visiting there.
Yeah, I'm based in Munich in Germany.
Okay.
Yeah.
Okay.
Yes, thank you so much for a great presentation and for for fitting us in your spare hours. We really appreciate it. Fascinating project. Really, really interesting what you're doing.
Yeah.
Yeah, my pleasure. I'm always happy to to talk to people that share the passion for robotics and doing cool stuff. And Seattle also has a big place in my heart because I've lived there for about half a year. In the summer, I have to admit. So I realized that if you're not there in the summer, you might have a different perspective. But
that's a good month.
They were months. I think those must have been great days.
Yep, they were. Was often up on Mount Rainier and driving up to the Bavarian village and like Levensburg and so on.
Yes. Yes.
Good times.
All right. Well, if there's no more questions, I think we will let our presenter go his way, and we'll just continue to have our own little, discussions here amongst ourselves. But thank you so much, Matthias. We really appreciate you joining us and sharing with us.
Yes.
Yeah, my pleasure. Thanks. Pleasure to meet all of you.
Yes.
And yeah, by the way, if you ever want to try out some of the OpenBot prototypes, we could probably send some through the foundation your way to just play around with, because they have been giving out some for education and other stuff. So I don't think that would be a big problem. So let me know.
Okay.
Yeah.
Well, that sounds cool. Yeah, we might have to take you up on that.
Yeah.
All right.
Then have a good one. Bye.
Yeah, you too. Goodbye. All right. Thank you, everybody, for joining us here. Let's see. So we can continue. There are a few folks there that want to continue to hang out and chat, maybe do a little post discussion about the presentation or anything else that we've talked about here. We can.
Well, I gotta go. So thank you.
Okay. Yeah. Thanks, Doug. I am going to, if we're all, well, let me see here before I dump recording here. Let me just let's see here. I'm going to get back to that. Back to that. Okay, so, oops, nope. Oh, there we go. Okay, that was the slide. I thought, oh, that's right. Yeah, I don't think I quite got to this slide here, so I just wanted to kind of hit this to no new information here, but same Zoom link, the same Zoom link next month. The meeting recording, as I mentioned earlier, will be posted up on the SRS website. We have fairly limited space on our Zoom account, so I usually have to pull it down pretty quick and then get it off of Zoom. And then probably within the next week I'll get the website updated, and I will be watching for Matthias's presentation, so I'll post that up there. And if you got any feedback for the meeting, feel free to send that to our email and post anything else that you think of in the chat here. That'll continue to. Well, let me see. I'm actually that might stop with the stopping recording too. I'm not sure about that. Actually, that's interesting. So anyway, I will with that I will go ahead and stop recording.